Alright, so our assignment sheet, this is again what I've been showing you. I just finally have it printed out for you. I still don't know our ESCO dates, so we're just going to proceed like normal. And if things change, I will let you know. But if things change, it would be for next unit, not this unit. So our test, unless we get snow randomly or hurricane, our test will still stay on April 24th. I'm supposed to talk.
I'm staying positive, Mr. Program.
Okay, so last class, you learned pyramids and cylinders. We learned prisms and cylinders. And we did, this class, we finished that for homework. And then today we're learning pyramids and cones. Now, again, you need to commit all these formulas to memory. But fortunately, our formulas today, pyramids and cones, are based upon what we learned last class.
So, for cones, is it just like the cylinder one, except only one base and the lateral areas have?
Close. It's a little different for lateral area, but basically that's yeah. Yes, Melanie.
So we don't have any quizzes for this unit?
Yes, it's next class.
Next class, we did not do that.
But we do just have one quiz that is a short unit.
Does the quiz next class today?
Today's lesson, yes. So we'll take our quiz, and after that we'll do our volumes of spiritual. Okay. So we do have a quiz next class, so that'll be over our stuff that we've learned thus far. So our area of the center, that's our cheese wedge. Our arc length, part of our circumference. And then we learned a lot of area formulas. Most of you already knew. Our new ones, kind of our new biggies for us, was our regular polygon. It's 1/2 apothem times perimeter. And our other new one that you probably did not know before was our rhombus and kite was 1/2 diagonal times diagonal. The other ones we talked about before. And then we learned last class one of prism and cylinder with our lateral area and cones area. And then today we're going to be learning these same 3 topics, but just now cone and pyramids.
It's a cone.
Cone, but I don't have a pyramid. Yes, Paul. Yeah, that's third quarter. So next class I should have updated grades, third quarter grades for you guys. I'm not for the mid-6 scale. Okay, so just a reminder that before break we will have learned all of our material and sneak in that quiz. Then we go on break, and when we come back we'll have review in our test. So you guys are looking at your test using 24. Okay, any questions with our pacing? Alright, and then I want to just go ahead and recap some of our information that we've learned so far. I've already written up here all the formulas we've learned so far. Just a reminder that with our cheese wedge, if we're looking for our area, that's just whatever fraction you have in your circle times the area formula for circle, because it's just part of your area. We want the arc length, that's just part of your circumference, so fraction of your circle times circumference. And then our apothem is from the center to the side. It cuts the side in half. Our radius, sometimes they give it to us, so that's why we have to use it. Our radius is from the center to the vertex, or vertices, and that can be 8.5. We use that information by our area for that. And then I just want to refresh memories on these vocab words here. What is a face? Who could explain spaces? Good, it's kind of like the sides of our what do we call the faces that are the same on top and bottom?
The base.
Good, the base. So like on a cylinder, those would be circles. Okay, what is an edge?
The line, like the connecting part of the 2 faces.
Good, it's where our faces intersect, which is like a line. And then our vertices is where our edges intersect. So then, what am I talking about if I say lateral edge? In general is where faces come together. What's a lateral edge?
The side.
Yeah, the edges on the sides. Lateral area was those sides that weren't the top and bottom. Our lateral edge would be the edges on the sides. So then what would a base edge be?
The one for the
An edge on the base. Yeah. So we have base edges on top and on bottom. Alright, I think that's like that. Height is just the height, the distance between our 2 bases. Or for today, because we only have one base, it's just the height of our solid. So from our base to that. Okay. So just a reminder with that, because today we're actually going to be using lateral edge. We've been using base edge all along, we just haven't called it base edge. But our base edge is again an edge of a base. Okay. So your homework, I've already checked some of it before, but I stamped the homework itself. So what I want you to have on your desk is there's going to be 2 stamped items. So your first homework was our cheese wedge homework. That has a stamp on it, so I want that out. And then day 2, there are 2 worksheets, but I just stamped one of them. So you just need to have the one that's stamped. So I should see 2 stamps. Then you're going to show me your homework for today. Your homework for today was our prisms and silver. So I should say 2 stamps, and there are 2 pages for today.
I'm thinking of stamp one.
Then just go and get it out.
Ah, Patrick, thank you.
All right, if I could have everyone to ask up front, please.
No, please.
According to the sun giant, my dear. Kyle, my dear.
How overweight? I was riding out, so.
Sun giant, let's go put our head up so we're
Yo.
less likely to.
Hello.
All right. What's the difference between a pyramid and a prism?
Pyramid creates different names.
Oh,
A pyramid has 5 ways, but a prism has.
No.
okay. So we have pyramid. So go back to prism though. How many spaces does a prism have? Actually, it kind of changes based on the shape. But you're correct that our pyramid will have fewer faces. Why?
I have more pieces.
Say it again, Matt.
It only has one base.
It only has one base. As Kyle said, there's no top. We only have our bottom. So we only have one base. What is that going to impact in terms of our formulas?
The total surface area.
The total surface area, because our total surface area would have normally for a prism have 2 bases, but for a pyramid we only have 1. And then for volume, it does impact our volume because would our volume be more or less for a pyramid? Less. And as you can see, it ends up being a third less. So our formula for prism was just simply area of our base times height. Well, for a pyramid, it's the same thing, just 1/3 of that. Our surface area formula for a prism was lateral area plus 2 of our bases. Well, for a pyramid, it's lateral area plus 1 base. Now, our lateral area is a little bit different. With our prisms, what shape were my faces? What were these lateral faces?
Rectangle.
Rectangles. And it didn't matter what my base was. The lateral faces were always rectangles. When we look at a pyramid, what are the lateral faces?
Triangles.
Triangles. So for our prism, okay, so for our prism, we, for lateral area, did our perimeter of the base, and then multiply that by our height. So we took our base times height, base times height, base times height, base times height. And that's because our faces were rectangles. Well now, because our faces are triangles, what's the area formula for a triangle?
1/2 base.
1/2 base times height. So I'm still going to keep the 1/2, that's where that comes from. Now when I look at my bases, if I were to add together all my bases of my triangles, that's still the perimeter of my base. But then this guy is different. This is what we call slant height. My slant height is if I were to take one of my faces, which is this triangle here, I want the height of this triangle. This is what we call our slant height. The height is the height of our pyramid. That's from the base to the point. But our slant height is going to be the height of our face from the base to the point. Those are 2 different values.
But how,
Yes, Dad.
is all 4 sides the slant height the same?
For our squares here, yes. Yes.
Couldn't you just call it an altitude?
Yeah, so the height of our shape would be like the altitude from the point to our base. our slant height would be the altitude from our point to the side there.
What do we use the slant height for? Is it for the side? Oh, the side of the area of the side.
What was your original question?
What do we use the slant height for?
The slant height for, so that's part of my lateral area. So your height of your solid is different than your slant height. Your slant height would be the height of your face. So as Cole said, the altitude of our face. Okay. So that's really our only new thing, is having to find that slant height. Everything else is the same in terms of what we're finding. Now, you can see here, because our faces are triangles, we're going to have to often use Pythagorean there. What else do we have with right triangles?
Oh my gosh.
The theorem.
6 theorem. 30, 60, 90, 45, 45, 90. And what other thing did we learn with triangles?
Tangent, cosine,
Sine, cosine, tangent.
Yeah.
So we will still have those come back at us because we are dealing with altitudes, and so that's right triangles. And our height is also perpendicular normals.
So that's gonna be calculator.
No, we still need a calculator.
For the,
Everything we'll do today is without a calculator.
that's what I like.
All right, so again, our slant height is the height of our face. Our height of the object is going to be the inside height of it. Okay. And then on our pyramids, sometimes they give us our slant height, as they did for number 1 here. They have given us our slant height was 13. Sometimes they give us our height of our object. For this one, our height was 8. But sometimes they don't give us either of those. For number 5, root 353 is this. What is that? What did we say that was called?
Oh, it was like
A lateral edge. Good. It's a lateral edge. So this is our lateral edge, our edge here. And again, base edge is just the edge on the base. So we're going to be using right triangles a lot. Again, it's a different right triangle for my face than it is for my height in the middle of our object. Let's just kind of take a look at number 1. It's really just plugging and chugging. The important thing is that 1, you know your formulas, and 2, you're able to handle our right triangles.
No.
Okay, so let's go take a look at number 1. Now, because they gave us our slant height, I'm going to start off with that. I need to find my height of the object itself. So I'm going to use the triangle that is made up of my height of the object. And my slant height, they said, was 13. So again, this is my slant height. Okay.
Wait, that's the slant. I thought the slant height was down.
So the bottom is 5?
Good, the bottom is 5. So this is just half of my base edge. How do I find my height? What do I have to do? Pythagorean theorem. Go ahead and solve. What is H?
Oh my god, this is.
I just can't.
What's so funny, Allison?
Nothing's.
Yes, 12.
Notice
I got 2 12s. Can I get a third
Yeah.
12?
12.
All
It
right.
is 12.
So our height is
It's
12. Why don't I use negative 12?
Because height can't be negative.
Good. The height, H represents the value for height itself. So height is 12. Good.
It's another 30, 60.
This one's not a 30, 60, 90, but you will have problems with errors.
100.
Not nice angles.
Oh,
base is.
Okay. What's my units for height though? Units. They didn't give us, so we just have to
The
repeat.
base is 100, right?
Right.
Is that all you?
That looks like a huge. I'm gonna try that.
Yeah, right. Where are they? Oh,
All right, area of our base. What shape is my base?
square.
Square. It's not always going to be a square. Flip your paper over real quick.
Wow.
It's not a square.
Is that a hexagon? Is that a triangle?
Notice here, it's not a square. What shape is that?
Triangle.
Triangle. How about for number 8?
Hexagonal.
We like hexagons. SOL really likes hexagon.
I don't like.
Why would we like the hexagon?
Because are awkward.
Because your hexagon,
Hexagon looks
this angle is 120, so when you draw on that radius, guess what type of triangle it makes?
36,
90. So we like the equilaterals and the hexagons.
You're
Okay.
so cool.
So what would be our area of the base then? 9 times 10?
100.
100
Yes.
squared. All right, our perimeter of the base?
But 40.
All right, so volume is 1/3 area of the base times our height.
How'd you get,
All right, so area of the base is 100. My height is
1/3 base.
400.
400
1/3.
units cubed. All right, lateral area. Remember, our faces, our lateral faces, are no longer rectangles. Our lateral faces are triangles. So our formula mimics that. 1/2 perimeter. And my slant height. My slant height is 13. 20 times 13.
Can I use a calculator?
No, you don't need that.
Oh, wait.
260.
Good, 260. Half of 40 is 20. 20 times 13. So double that.
Oh, it's just that's 30.
Numbers, more.
All right, our total surface area is still our lateral area
What's the L?
plus one of our bases. We don't have two bases, we just have one.
That was, oh, that's plus.
So plus 100.
X about 360. Wow.
So weird.
All right, do we have any questions on number 1?
So L, the little L thing means a slant.
Slant.
You number 2.
Yes,
Are we
I
doing about your
you will be doing it for homework.
Like with a base.
Yeah.
240 divided by.
Do we have questions on number 1? Do we have questions on number 1? Yes.
Why'd you say the bottom one, like the triangle, when you're trying to find the height? You say that one was 5?
So the base edge is 10. This comes down in the center, so this will always be 9.
Even in like the triangle and hexagon thing, or some different thing?
So for our triangle one, so for this one, you're gonna have to do a little bit of work. So this will still be half, like that will be 3 when you go to do your slant height. Yeah. I don't think you need your radius for this. And then, like, same for this guy. So when we go to do our slant height, it's kind of hard to draw their slant height. So there's my slant height. So it'd be 6. Okay,
Numbers. How could you?
all right, let's go ahead and take a look at number 5.
Divided by B.
Patrick, I must feel like I want to take back what I said. I need to look at it again. Okay, number 5.
It wouldn't make sense.
That definitely looks like a division.
It is plus. Guys, this is a plus sign.
That jaunt looks like a division. That looks like a plus sign.
They're being dumb, okay?
All right, number 5 I would like to do next. I'll wait for you guys when you're ready.
Like if you get a radical. And it could.
I wouldn't because it's squared anyway.
What?
Okay, for number 5, root 353 we said is a lateral edge.
Yes.
So now I want to use that to find my slant height. So I'm going to draw that off to the side.
That would be an 8.
Oh, it's definitely a 30, 60, 90.
Now, again, how much is this?
Oh, my bad.
Wait, what did that do?
You're so
All right, how do I find my slant height?
Well, you
Pythagorean theorem. Go ahead and find your slant height.
64 plus L.
Adam.
No, I looked at it.
Isn't that the slant height? Isn't smaller?
The root 353.
Yeah,
That's our edge. It's where the faces come together.
How many times is 4?
What's the square root of
17.
Thanks for being smart, Kyle.
I appreciate that, Kyle. Here.
What is 17?
Yes. Yes. Big
No RBC.
What is it? Victory?
Yeah.
What?
Big.
Max number I know, 14 is 196. Oh, no, I know, what is it? 15 is 225.
I'm gonna try.
What time is it?
Oh, it's 17.
7!
I'm just
Seven equals 49.
Oh, 17.
It is 17.
We have met your genius.
Yes.
All right, what did we get for our slant height?
17.
Now we need to do another triangle.
Yay.
We do need to do another triangle. So now we're going to do the triangle that uses my height of the object going out to my slant height.
17.
So I have my height, I don't know, my slant height was 17. And how much is this again?
8.
Why were they both 8?
Because you're.
This is a square.
Because it's a square. Good. So half of 16 was 8, and this is still the same
The
size.
base is,
All right, go ahead and find your height.
Why is
It shouldn't be because our hypotenuse is 7.
16 times 16.
Let's go.
What's that?
it's a
Rotating 256. It's 15.
it's 15 ladies.
No, I know, I'm just going ahead. And I'm
Stop. Stop.
Yeah, I'm trying to go ahead. What's, math, 16 squared.
All right, what did we get for our height?
256. You can't say your Jesus.
What's our height?
15.
15.
What's number times the other number?
All right, area of the base.
The base is 256. Base. Boom. Genius.
Perimeter.
64.
Yay.
Make sure to add the units.
I don't know.
All right, so now for volume. What is your volume formula?
1/3 base times height.
Thank you, Anna. 1/3 area of our base
I don't know.
times our height.
100, 1,200.
What's 1/3 of 15? 5. So 5 times 256.
700.
1,250.
Wait.
1,280.
Why'd you do 1/3 times?
25 plus 3.
Oh, why'd you do 1/3 times 15?
Yay.
Instead of all.
Because
It's easier to do than 256.
Oh, I see it on this.
1/3 is easier to do than 15 than 256. It's a commutative property, so I can rewrite it however I so desire.
I love that.
Oh, yeah.
There's 26 minutes. I wanted that.
All right, we should have gotten 1280.
Yeah.
Yes, you will sometimes have to do multiplication by hand.
Oh my god.
I actually saw how to multiply like
Could
All
I?
right, our lateral area. Our lateral area is 1/2 perimeter times what?
Slant links.
Slant height. Good.
So they're
I would not recommend doing half of 17. What's half of 64?
32 times 7.
I hate big numbers.
This could literally be a test.
This could very well be a test question without a calculator.
No, I'm saying like, we learned so many shapes, this could all go. The quiz.
The quiz is gonna have one.
All right, do we have questions so far?
Yeah. Piece of paper, rectangle.
All right, our total surface area
Zach, are you okay?
It's 540.
is my lateral area, and what do we add to it?
250.
That's terrible.
Just one base.
Divided by.
No, it's close.
It's okay, I mean, it's a plus sign.
Yeah, 800.
Zimbabwe.
I think it's 200.
Someone get the staples button.
Are you sick?
You can't concentrate if you're distant.
It's called Excel.
That's not appropriate.
It's a long time.
I can't learn any more shapes.
Enjoy yourself.
I need them for my visual.
That's what I
I still wish I stopped unlocked.
Every map like that.
So here, so it's area, oh wait, sorry, I was in
Jocelyn, I'm Jocelyn.
So it should be area of the base times.
Should we just make it right?
Is that a 9?
But she's gonna like, I can like do bad on the board.
Alright, is there anyone that did not get cones?
Oh, alright.
No, he has one last home game.
I know.
Did you do it times the height? Or the slant height?
Greatest player ever.
Like the, I haven't had it.
Second best shooting guard.
I have getting red for both of them.
There's not a part that you don't have factors for. Cricket's always.
Yeah, it's not better than
Alright, I'm ready when you are.
I'm trying to learn, shush.
Alright, cones. Cones are the exact same thing as pyramids, but what is their base? Circle. So same formulas. The only thing that really changes, isn't really a change, is what do we call the perimeter of a circle? Circumference. So otherwise our formulas are exactly the same.
What number is that?
The things you want to be careful with is when they sometimes will give you diameter instead of your radius, so you need to find your radius. But actually I feel like our cones are a little bit easier because since there aren't flat faces, then we don't have to worry about, like our slant height is a little bit easier to see on the picture. Slant height is just a hypotenuse there with our height impact. So you just be mindful of when you have a radius, or when they give you a diameter, and instead you want to use your radius. All right, let's take a look at number 6.
Hey,
Did you figure it out, John?
oh, it's 3069.
What type of triangle is it? It's a 30, 60, 90 triangle.
You got what numbers?
What did they give us in our 30, 60, 90 time?
Long side.
What did they give us in our time? Hypotenuse.
That's three.
So my hypotenuse is 6.
The height is
Is my height 3 or is my radius 3?
The height is 3.
The height is 3. How did you know the height is what?
Because it's the smaller side and the 30 is the smaller angle.
Good. 30 is across from my small side, and so I take my short side, which is the height, just across. All right.
The height.
We probably need our radius. Let's go and find it. What is our radius going to be then? 3 root 3. All right.
Yeah.
So for a 30, 60, 90, the hypotenuse, where's the short leg is just half?
Yes. Yep. Your hypotenuse is 2 times your short.
Where's curve?
All right. So my radius is 3 root 3 units. My height is 3 units. What's the area of my base? What's the area formula? Pi r squared. It might be helpful to think that for area, our units are squared, our radius is squared. So my radius is 3 root 3, so I need r squared times pi. What is 3 root 3 squared? 27?
3.
Do we agree with 27?
Yeah.
Yeah, it's 19.3. Who can explain to me why it's 27?
Because if you separate it out, like the radical, it'll be 3 times 3 times root 3 times root 3. And then if you just put those together, you get 27 pi.
Good. 3 root 3 squared, you've got 2 ways you can go about it. Square, which is 9. Square your root 3, which is 3. 9 times 3 is 27. Or you can write it next to each other, and then commutative property says 3 times 3 times root 3 times root 3. This is 9, this is 3, multiplied is 27. Thank you. All right, what is my circumference?
6 root 3 pi.
Stop.
6 pi.
Oh, what's that?
It's 6. Isn't it like 6 root 3 pi?
Yeah, it is.
6 root 3 pi. Do we agree with that?
Yep.
Wait, where does this red come?
Because it's pi.
So it's our diameter times pi. My radius was 3 root 3. We want to double that, 6 root 3. Now, I would not recommend writing it like this. I would recommend writing it like this. Why?
What?
So that you don't think.
Oh, you don't use multiplication.
Yes, I don't want that pi to sneak under the radical. You can write it this way, but you're taking the risk. If you write it like this, and any part of that pi sneaks underneath,
Bueno.
wrong.
It's the whole
I would not recommend doing this. Put your radical last. With your radical being last, it's easy to see 3 is the only thing that's underneath.
And we can also
Alright,
in front of
Let's not forget our units. Thank you. What are our units for circumference?
It's not units.
Units.
Just units.
So long.
No squared.
Oh, it's only circumference. Sorry.
All right, volume. What is the formula for volume here? 1/3.
One.
So it can be 27.
I don't know.
Lateral area.
36 pi root 3.
Oh my god.
Next thing you know,
They got head, baby.
Oh, you keep the pie?
What is the formula for lateral area?
1/2 circumference times length.
Well, you're supposed to use the cubits.
1/2 circumference. Very good, Zach.
That's a smart.
6 pi.
So 1/2 circumference
Or
times our slant height. What was our slant height?
or
Slant height is 6. 6. That's what they gave us. So what does this become?
3
Times 6?
18 pi.
3 pi squared.
How much pi do I have? 18 pi root 3.
Wait, where'd you get the?
And then you add the base.
Where do you get that L from?
Oh, they gave it to us.
Don't risk it.
Risk it.
Alright,
I just saw it.
I was flew
I
by.
feel like.
I don't know, pie.
what's 1 half times 6?
Oh,
3
times 6.
And 3 times 6? That's right, 18 came through. Then I still have pi, and I still have 3. Alright, our total surface area, we keep our lateral. We add to it 1 base. Alright, what's that combined to be?
45,
Is it 45 times 3?
Oh, wait, no. It's that.
We can't do anything with this. Good work, Ellen and Kyle, on catching that.
Wait, can you explain the clock?
Because
So this is a root 3. This one's not a root 3. So here I have 27 pies, here I have 18 pi 3s, 2 different types of things. So this will be our final answer, except we still need our excuse. Any questions with that? Great, flip it over to the back side. What kind of Because this is root 3 and this is not. They have to both be the same radicals to combine them together.
And number 1, does it say 12 to the 4th power? Like, what's that tiny little thing over 12?
Oh, those were inches, the inches.
Oh.
I got a little word as I go through my exponents, except for units, squared, and units. Alright, on the back side. Look at these problems down here at the bottom.
Oh, that's not a psychedelic.
You got it.
Oh, it's fine though.
Oh, it's not like two separate equations.
So this is just like our problems on our last homework. These are called composite shapes, which means we're taking different shapes and adding them together, subtracting them. So for number 11, it says to find the total volume. How would I do that for this? What would I need to do? Go ahead, Lee.
You would need to find the volume of the cone on top and then the cylinder and add them together.
Yes, for number 12. Good.
Oh.
So then for number 11, what would we do?
Oh, my bad, the two cones.
Good, and we'd add them together. Now for 13, what would we subtract? Good. So I would want to take that cone away from the cylinder. Essentially, that would be this shape. I would want to find the volume of this. The cone is empty inside. I would want to find the volume of this right. So I want to find the volume of the whole cylinder and take away from that the volume of the cone. Now, these all ask for volume. But it's very possible they might ask for surface area instead. So we're not going to necessarily go through and actually find them, but I just want to write off to the side. I want you to write this as well. If I was trying to find surface area, what would we have to do? What would change? So for number 11,
Subtract base.
if I wanted to find my surface area for this shape, what would I need to do?
Subtract the base.
Subtract the bases. Good. What do we call this? The I don't know how to describe it without saying what it is. The lateral area, yes.
Later.
So our lateral area, wouldn't that just be the outside of it?
Yes.
And would the lateral area down here just be the outside of it?
Yes.
So can we maybe, instead of doing surface area minus the base, just do lateral area plus lateral area?
Yes.
Does that make sense?
Yes.
Now, are these the same lateral areas?
No.
No,
So
why
you'd be
not?
lateral area 1 minus
Are we subtracting?
Yes.
I mean plus, sorry.
Why are these different lateral areas?
Because they're different heights.
Yeah, they're different heights. They have the same radius, but they're different height cones. So I would want to find the lateral area of this guy, find the lateral area of this guy, and then add them together. So our surface area is really, for this particular object, our surface area is just simply our lateral area of the top plus the lateral area of the bottom. I'm just going to write T and B for that. Now for 12, this is a little different. We've got a cone in a cylinder. So how could we go about finding our surface area for this guy?
we're missing one base.
We're missing one base,
Or two?
two bases. For my cone, do I have the base?
No, no.
No.
Yeah.
For my cylinder, do I have both bases?
Yes.
Just the one, right? We just have the bottom.
Wait, why?
So it would just be lateral area plus the.
I have this base, that's one. What happened to my base here, though?
It's that here.
Inside, it's not a part of my surface. Surface area has to be on the surface. So if I were to take this here,
Looks like a Tin Man.
my base is inside here. It is not a part of my surface, so we would not have that. So for my cone, what would I be taking for my cone?
The lateral area, or the cone,
The cone, for the cone.
Just the ladder.
Just the lateral area, right?
lateral area, and
The
then.
base is inside, no longer part of the surface. So for my cone, I would just take my lateral area, I'm gonna write lateral area of the cone.
And then
Now for my cylinder, what do I
the
want?
lateral area.
Yeah, my lateral area plus one base. Or I could say surface area minus one base, however you want to go about it. So I would do my lateral area of the cylinder plus one base. Again, you could say surface area of your cylinder minus this base. Okay. I'm not gonna make you do, we're not gonna talk about surface area.
It used to be a minus.
Let's talk about it. Okay, I take it back.
Minus two bases.
You just subtract it.
It's easier to understand.
Oh wait, thank you.
What if we had to do surface area for our last one?
Surface area.
It's just minus.
Yes, Lee.
How do we know whether it's like hollowed out or something?
Because it says outside but not, or sorry, outside cone but inside cylinder. So this shape here.
Oh my gosh.
It's the same. That's the surface area of the line.
Why?
Because you still remove one base and you still add.
Good. So Cole said this is just gonna be the same surface area as number 12.
Okay, mine.
Because for my cylinder, I still have my lateral and one base, not the second base. And I still need my cone lateral area, but not that base, because right, it's open on top. So it's actually the exact same as 12.
Do you add them together?
You'd be adding them because this is a surface. This is a surface. This is a surface. And here is not a surface.
What? Okay.
It's kind of like if I had to paint all the surfaces, how much a square inches of paint.
That's an SRO problem.
Yes, Jade.
Could you just start
See you
by
later.
making the total surface area of the cone and the lateral area of the cone? Both bases are the same thing.
Say that again.
So if you take the total area of the cone, that's one of the cylinder bases,
Mhm.
and just do the lateral area of the cylinder base.
Yeah, you can do it that way instead. Yeah, so Jamie's saying just do the whole surface area for your cone because that would take care of the base for your cylinder and then just lateral area. Yeah, so there's definitely different ways you could go about this, but yeah, that would work as well. Yes, Cole.
Oh,
How do you calculate the surface area?
Oh, what?
Like,
Am I supposed to know what you're talking about?
no.
Okay.
it's got one face and no edges.
So to the,
It's three.
Hopefully I get 100 on this pen.
oh, why do you always go to another world with me? Okay, so now the fourth dimension.
Time.
Great question. I don't know.
Google it.
No, teachers aren't supposed to know everything.
This is
There's no way to know everything.
one lesson.
Teachers are supposed to know everything.
Okay, yes, Lee.
I don't know, like, what if, cause what if the,
You don't like that last one, do you?
no. So like if the cone's on the inside, what if the base is just like, if the base is still there, I don't know whether to like subtract, or the other base though. Like what if the cone is in there, but the base is still there, would we just do the surface area of the cylinder?
So they would have to describe it a little more and say that we have a cylinder with a top and there's a cone removed from the inside. So our surface area,
Would they probably ask for the
I feel like they'd have to specify too because that sounds like something we would do for calculus, not surface, because we don't do surface. But that sounds like something they might do where they would want you to find something about the volume of it. For geometry, they would have to describe it better. They would have to say cylinder with the cone removed, but still has a top. And if they wanted surface area, they would have to specify surface area outside and inside.
No, you're fine.
Are there other questions with this?
Yes,
Yes, Councilor.
like, I don't get it, like how you tell like the structure.
Surface area is whatever is on the outside. So for the one where it's a cylinder covered, this is on the outside, it's a surface. This is on the outside, it's a surface. This is on the outside, it's a surface. I don't have the space here because that's now inside my string.
Yeah, it is.
Whereas if I had a cylinder, I would have the base on top and the base on the bottom.
So then when you do it, this, so how do you know?
So then surface area. So surface area, I would do the lateral area of my cylinder, and I have one base. So my lateral area of my cylinder,
And that's all like.
lateral area of my cylinder, I have one base, and I have lateral of my cone. I don't have the base of my cone because it's now inside my shape.
No, I can physically, how would you like the formula?
I mean, you'd have to find each individual thing and add it to it.
For this sheet, do you have to do the surface area?
No, it's just, it only talks about line, but surface area kind of gets changed a little more.
To do what?
Are there other questions with this?
To test.
Basically, like, turns around.
Okay, so let's take a look at, I think I want 10.
Whoa, no.
Jocelyn says yes to 10, so let's do 10.
Dog.
Like, when you enter, you can get
Alright, so it says volume of the cone whose radius is 7 and total area is 224 pi. So what is our volume formula for a cone?
1/3 of its inside.
1/3 area of our base times our height. Alright, we're supposed to find the volume, so this is what we're trying to find. Okay. Can I find my area of my base?
No.
Yeah, because the radius is just pi r squared.
Yeah, it's just pi r squared, right? We have our radius given to us. What is our radius?
7.
So I have 1/3. So pi r squared, 7 squared?
49.
49 pi. Now, do I have my height? No, I still need that. So I'm going to just write h. They didn't tell me my height. What did they tell me?
The total.
Good, our total surface area. So let's write out our equation for that. Our total surface area is our lateral plus, how many bases?
One.
Just one base. All right, they told us our total surface area is 224. Now, what's my lateral area formula again? 1/2 circumference times slate height. Do I know my circumference?
Yeah,
Yes.
we can figure it out.
We can figure it out. What is it?
It is 14 pi.
Good, 14 pi. Radius is 7. 2 pi r. It's 14. So we know our slant height. Okay.
Also, what's your area?
How about area of my base?
Yeah.
It's a circle. What's our area of base? Pi r squared. Let's throw down my pi.
49 pi.
49 pi.
Speaking gibberish.
So we need to find the volume. But in order to find volume, we first have to have our height. But I don't know my height.
We have to get.
What would I need to find my height? Slant height. If I have my slant height, then I can do Pythagorean theorem. Do I know my slant height?
No.
No, but we can find it. So let's find it. Go.
1/4.
No, let's.
Wait.
Yes, fine. What's your question?
I have many questions.
So go ahead and find your slant height. It's just solving. Don't look at me. You do it. I've already done it.
That's unfortunate.
I'm not even looking.
11.
Volume. So I said my volume. But I don't know my height. So I stopped and said, okay, what else do I have? They also give my area. So
So that's why I went to our surface area. They gave us that. We just plugged it in, I guess we did. Area of base. Area of base, it's a circle. Ladder area, that's a form of area.
Pi is gone? Where's the pi? Pi's still alive.
So 1/2.
UVA lost in 60 guys.
What's your guys' color?
Solar pattern.
It's the word math. What's that?
Exactly what you mean.
Now I'm gonna go home and look at the question. Have my calculator.